Okay, so today class is about application of linear programming. So we go over some different applications, and in each application we learn how to formalize it. The way that you learn linear programming is through so many examples, or actually type of examples. So you can learn how to formalize it. So in this class, we don't go through mathematics behind of linear programming and how to solve it. But the algorithm that we use is simplex, and you can see is under algebra as a general topic. But anyway, so it's not like you memorize some specific formula. You just need to know how to formulate it, how to transfer a text document to some equations, and then let the computer to solve the equation for you. Having said that, before starting the applications, I think I'm still waiting some of you to join. I think I guess 30% of the students are not coming yet. So let me show you another software that you can utilize it for linear programming. The name of software is Lingo. So let me just go over to its website, Lingo for linear programming. And you can download Lingo from here. And as you see, Lingo version 18 for Windows or Mac or Linux, whatever version you can use. If you have time, next class I go over that, but basically it's even easier than Excel. You put your, basically the way that to type formula is like how you write in your paper, and just let Lingo to solve it for you. In some aspects, it's much easier than Excel, but Excel also has a lot more capabilities, so there's a trade-off between them. But basically, Lingo is specialized for solving linear programming problems. I think you can study a student version. A student version has good capabilities. So if you have time, next session I go just briefly go over that. But meanwhile, you can just download it, and it doesn't need that much programming. Basically, you just type whatever in your mind, and it solves for you. But anyway, I mean today. We go some applications and solve it through Excel. So please go on Moodle and download the documents and Excel files. So because later I open those Excel files on my system and you can learn how to solve it. So I give you like a few minutes to just go to Moodle and download the files that I put over there. Okay, while you're downloading, let me go over some reminders. So next week we have our last quiz from week 9, 10, and 11. It's similar to previous quizzes. So in terms of format, it might be, you might complete some blank spaces or like multiple choice, and some questions, probably you need to do some calculations or type something. But it's pretty similar to the previous exam. Also, we have a presentation contest. I think many of you went to the next step. So in the next one, please make make an impressive presentation. You don't have to be very smart in calculation, but it's needed. You need to have good presentation too. You need to transfer the your working process and just explain everything, details to the presenters. I think you have at most 20 minutes. You're supposed to present in person, but you know we are in the quarantine time, so you need to make a video or voiceover. Just make just do the best thing that you can in terms of presentation analysis, but you should good in both parts. I mean, in terms of innovations, one of the things that I look at your abstract that lacked was innovation or good applications. I can see I've seen two good abstract about COVID-19. It was impressive. Some you used very old like problems that are in Kaggle, but that's fine too. But I'm just saying that try to be more competitive in terms of the analysis you do, your outcomes, and your presentation. So week 14 is for whom who wants to do Zoom presentation for me. You don't have to. You can make some online videos and send it to me, but the last class, week 14, is for those presentations. And if you look at the syllabus, the due date for your report is 29th of April, 11:59 p.m. So you should submit everything by then. You are more than welcome to submit sooner, but this is the due date that you need to follow.
Professor, I have one question.
Sure.
You said that on April 22nd, we have to give the presentation online, or we just have to submit it to you?
Well, I mean, if you present to me through Zoom, I can, if I have questions, I can ask you. So might be some, I mean, it depends if you like this way or not, but if you submit it like as a file or a YouTube link, if you have any questions, I just need to figure out. I'm not sure if I can figure it out, but probably if you present in Zoom, it's much easier to communicate with me.
Okay, so, all right. So every group has to present on that same day?
Yes.
Okay.
But you don't have to, just that it's an option, and you can send me a video file, YouTube link, or voiceover over your PowerPoint.
Thank you, Professor.
You're welcome. So the last exam is a take-home. It's the only option that we have. So it's not that it won't be an online exam. I give you problems, and you might have at least a couple of days to work on it. So just keep in mind, I mean, it should be some larger problems. And I mean, there's a good and bad thing about take-homes, but it's the only way that we can do it at this time. So might be easier, I'm not sure, but let's see what you do. The submission is or would be over Moodle, so I make a section for you to submit your files, and it's mostly like a report thing. It's not like simple like questions that you can find it in the book. It's more analytical understanding of the course. So any question about the exam, presentation, contest?
So I have one question for the
Sure.
quiz. Last week there was one question. I think that was we have to find the confidence, right, of the metrics.
Mm-hmm.
And so what was there? I checked with the TA,
Mm-hmm.
and he said that we have to also provide the definition of the confidence and all those things. But though we were happy to, but we don't, like, the question was not specific that we have to give.
No, you didn't have to. So I can, and even in the, like, if you remember the link that I sent you in on top of the page, I said you don't, the even final answer is enough, but if you provide your thinking process, maybe we can give you partial credit. So let me talk with him. If your final answer is right, you get the total.
Yeah, so he confirmed that my final answer is right and the steps of the calculation was also right.
So yeah, you don't have to provide definition. You should get full credit. So let me just talk with him and let him know.
Thank you, Professor.
You're welcome. So any other questions? I wait like it's a like online thing. So I give you like 1 minute or two the thing, to see if you have any questions. You can even text me if you are not comfortable for voice or video. So okay, go to next one. So last week we talked about general linear programming, what does binding constant, slack, surplus, shadow price means, and we had some examples. Also, we had some two applications, two very basic applications. And as I said, the way that you learn linear programming, you need to expose yourself to more problems because each problem is unique, is not similar to other problems. So it's not the way that you do a problem, maybe next problem would be very difficult for you, I cannot solve it. So you need to see so many types of different problems, and then if you get something that has some similarities with those types, it's much easier for you to solve the problems. Otherwise, it's not the way that you like integral or derivative that you can memorize or learn some methods. It's kind of like you need to be very smart and think what is going on and use in your probably your IQ to see how figure out, because the most difficult part is how to formalize um, like the real case scenario. So today we go over three types of problems: transportation, scheduling, and assignments. So we will have some discussions to see how to solve it. No worries. I expect that it might be a little hard for you because first time you see such such applications, but next time it just gets easier and easier, and it will be like a piece of cake later for you. For now, if you want, and I also put the solution on Moodle, so don't worry, so you have enough time. Even if you didn't catch it, you don't need to like take notes because everything is provided. So I hope you downloaded Mm, the five that I mentioned to you. The first problem that I'm going to look at is transportation problem. So just generally speaking, in the transportation problems, let me use my whiteboard. Just wait a moment. So stop share. Okay. Oops. I need to log in with my whiteboard so you can understand what I'm doing. Okay. Oh, unfortunately, it seems there is a technical issue. So just let me see what can I do here. Guys, can you hear me?
Professor, your voice is echoing.
What about now? Can you hear me?
Yes, Professor.
Okay, that's good. So let's talk about transportation problem. Or just speaking, we are talking about supply chain problem. So in such a problems, generally speaking, our objective function is to minimize the cost. So, but let's look at the breakdown of the cost, or cost breakdown. So, can anyone has idea of what kind of cost we might have in transportation? In transportation problem.
Logistic.
Yes. Mm-hmm. And goods itself, right? You are.
Yeah.
We can make the problem harder and harder. Maybe we can add warehouse problem or warehouse cost. But generally speaking, logistic, or if you use trucks, it's basically the cost of the truck, either gas or insurance, as one of you said. So all of them, or insurance could be about the cost, I mean, goods and warehouse costs too, but these are basically the general expenses that we might have. Okay, so let's talk about the limitation that we might have. So let me just raise it for you now. Or constraints. So let's talk about supply constraint. So what's your idea which about the supplies or supply? So how much you can supply in terms of quantity? Let's say you have a factory or 3 factories here. Each of them can produce 100 units of Nike shoes. And so if each of them has capacity of 100 Nike shoes, how much Nike shoes you can transfer? Let's say this one can produce 100, this one 100, and let's say this one 50. Basically, you can say your supply should be less than your capacity, right?
And it also depends upon demand.
Yeah, I mean, it depends on demand, but you can, but it's possible your supply is more than demand, so you lose something, right?
Right.
But it's not logical that your supply, let's say you can produce 250 Nike shoes, doesn't make sense that you say I'm my capacity, if your capacity is 250, it doesn't make sense that you say I supply 500 Nike shoes, because you can just supply 250.
Right.
I'm just talking about logical constraints, but you're right, you know, if your customer needs just 200 Nike shoes, if you produce 220 to 40 or 250, you are losing some money.
Right.
Yeah. So, but that comes from, we answer that question through objective function, because our objective function is minimizing the cost. So the way that linear programming works, through objective function, it takes care of your benefits or costs. So in the way that we formulate and the logic that's inside the simplex algorithm, it takes care of those economical interests. So, or, you know, it's not just only for goods, it's for your transportation capacity too. For example, if in this link you can send 2 trucks, this one truck a day, and this one, let's say 5 trucks, your truck capacity is like 8 trucks a day. You cannot say I'm using like 20 trucks, because in those roads you can just, at most you can use 8 trucks. So you can consider transportation as a kind of supply, because you're providing it. And okay, so let me just, I have some space limitations. Oh, sorry, let's just erase. And another one is about warehouse. So outflow should be less than inflow. In this example, you cannot say the inflow of shoes is 200, but the outflow to the customers is 400. It's not logical at all. So you might keep something in your warehouse. You might lose money for that. You might waste money for that, but it's logical. You can just keep some extra shoes in your warehouse. Any questions so far? Okay. So what about customers or demand? You know, it's not that much of logical constraint, but we want to have our delivery more than our demand. You might have some more complex problems that if you don't satisfy your demand, you get some penalties, and it goes through your objective function. But for this class, we won't have this constraint, which our delivery should be more than our demand. So our supply is less than our capacity, but our delivery is more than demand. And you might say, why we deliver more? I mean, if you deliver more, you lose money, and it's not good. But it's the way that, but your objective function takes care of that, because you're going to minimize the cost. So your delivery is better to be equal to demand, or not too much more than demand. Okay, so this is the general logics behind the transportation problem. And now we want to just open Excel file, or even in the lingo, you need to type it. So basically, we want to transfer those logics into equations and calculations, and let a software computer or Excel solver or Lingo or whatever to solve it for us. And this actually, for linear programming, the most difficult part is just understanding the logics that you need to implement. Because you will see in the other applications, the logic is kind of different. So, but like if you do one transportation problem, probably the next one's just, it will be very similar to this. So you would be solving the next transportation problem should be much easier for you. Okay, so let me go back to my PowerPoint. So I need to, let's see how, stop sharing. Okay, so, okay, let's look at this. I think you cannot see my monitor, so let me just share. Okay, okay, look at this transportation problem. So on the rows, you see your suppliers, Dora, EU, and Claire are suppliers. And Ocala, Orlands, and Leeds are our customers. Oh, sorry, I said opposite. So demand comes from customers. So Dora, EU, and Claire are my customers. Supplies is for supplier for sure. So Ocala, Orlando, and Leeds are my supplier. And you see a unit cost in this table. For example, if you send something from Ocala to Dora, each unit costs 21. If you send a unit of goods from Leeds to EU, it would be 22, and same for other. So, in part one, if one truck can handle 300 units, and cost of one truck for each location is given. So you can send 300 of units from Ocala to Dora, at most 300, maybe you send 200 units or 50 units, but the truck would cost 200. If you send like 344 units, sorry, if you send like let's say 50 units from Orlando to Dora, it costs you, the transportation cost is 344, and same for others. So basically now we have two costs. First is cost goods. So, and the second one is transportation cost. We need to satisfy a demand using our suppliers. And part B, the truck capacity just dropped to 100. So again, part one and part two are pretty similar. And we just try to minimize the cost. Again, so we have certain suppliers and certain customers. So basically demands is for customer, supply or capacity is for supplier. We know the unit cost from each supplier to customers, and we also know the truck cost. We want to say how many trucks from a specific customer should go to a specific sorry, how many trucks from a specific suppliers should go to a specific customers. And if you find out how many trucks we should send, we can calculate the transportation cost. If we understand how many goods should we send from our suppliers to customers, we can understand the cost of the goods. And the summation of two makes our total transportation cost. Here, the problem is not that much complex because we don't have warehouse. But if we have warehouse, we just need to add the cost of warehouse, and we had also constraint from inflow and outflow. But here, our problem is easier. So I give you 5 or 6 minutes to think about that. So just before this problem, I show you on my whiteboard what kind of constraint and objective function we might have. That's okay. I don't expect you guys to solve it. It's first time you see such a problem. I just need you to think about that, and then we go over the solution. So I give you like 5 minutes to think about this problem, and then we go to the solution. Okay, so let me just open the Excel file. So you might see there's a transport underline truck docx or document, and there's an Excel file. Let me just make it bigger. So first of all, we know that total cost is the transportation cost plus the goods cost, which supplier provides to which customer. We want to minimize the total cost. We should satisfy demand.
Professor, we are not able to see the Excel.
Oh, we can now?
No.
Oh, just let me check. Okay, let me share it again. Can you see the Excel file now?
Yes.
Okay, good. So again, I provided on Moodle, so you can download and open it by yourself too. So again, total cost is the transportation cost plus how much we pay for the goods, because based on the table that I provided to you, if you send some goods from supply to customer, you might pay different amounts. We should for sure satisfy our demand. Again, I said in some complex problem, you see that if you don't satisfy, you get some penalty. But for case of, for the sake of today, we assume that we should satisfy demand. And it's not logical, or we cannot deliver more than what we supply. And also number of trucks are integer. It's another constraint that we have. We don't have 1.5 truck. So it is either a truck or not a truck. And we have two tables. A table for cost of each unit of the goods, and also the cost of each unit of truck. So, for example, from Ocala to Dorna, if you send the 2 trucks, you should pay 200 times 2, 400. Okay, so you see that I provided some blue cells and some yellow cells. Blue cells, it means the cells that Excel should calculate. What the Excel Excel solver calculates for you. In this upper one, it calculates the amount of the goods that you send from a specific supplier to customer. The below one, Excel solver calculates how many trucks you need to send. And yellow one comes from our formula. For example, look at this giant yellow rectangle. If I click on the formula, it just shows based on number of trucks that Excel solver calculates for me, it multiplies to 300, which is the capacity of truck. I can understand basically the total capacity that I could have here from a supplier to a customer. So based on what Excel calculates for me, I can understand the capacity that I have on a specific link from supplier to customer. And based on this, the upper blue table, I can understand how many goods I'm sending from a specific supplier to customer. If I'm, instead of 300 for each link, I have a specific, basically unit cost, and if I multiply amount of goods from this table, this one, I can understand the total cost of the goods. So basically, I'm telling Excel to find me how many trucks and how many goods I should send on any link. Again, we don't go over the mathematics behind of that, but if you if you want to learn for your information, then just the algorithm. The algorithm or mathematics is simplex algorithm. And you can study by yourself if you're interested. And this basically topic is generally going under operation research. And somebody even can get a PhD of operation research. So it's like a very big field. Like in this class, just look at some very simple problem on specific applications. Okay, look at this one. I said, based on whatever Excel calculates for the number of goods, multiply the cost of their cost, and give me the total cost of goods. And based on how many trucks it calculates in the lower blue rectangle, multiply to the cost of each truck, and give me the truck cost. And the last yellow one is just summation of goods and trucks cost. And I can understand that my total cost here. I just wait like a couple of minutes to see if you just play with that. And if you have any questions, ask me. Then still there is something remain that I explain more, but just I give you like a few minutes to play with this Excel file that we downloaded on your system. And then I go to the next part.
Professor, I have one doubt.
Sure, please ask.
In the document, that Word document, it's given that the demand for DORA is 275, but here in the Excel sheet, this is referencing to the supply cap. Like this is the demand.
Yeah, you're very right. So you should change it to demand.
The below one is supply cap, 206, 225.
Thank you very much. Yes, there's a supply. There's a typo here. Thank you very much. I appreciate it.
Thank you, Professor. I thought there is some confusion. I'm not able to figure out what was that.
No, you're very right. I mean, actually, the first problem had some issues. I fixed it, but I forgot to fix it in the Excel file.
Okay, thank you.
Thanks. You guys can click on the like yellow cells and see how those formulas is working. And also I recommend just go back, read the Word document, then go back to Excel, just go back and forth multiple times. So hopefully you can understand what is going on there. Generally speaking, operation research, or I mean, these kind of problems, linear programming, at first might be a little scary and totally understand. I mean, it's because there is no general solution for every problem. In every problem, you might, sometimes you need to think hours to figure out how to formulate. But it's really interesting and very applicable. I can say there is so many applications. If you want to go to the supply chain track, probably you need to know a lot about operation research. And the good thing, if you go to industry, you don't need to know how to solve this problem. You don't look at the mathematics behind it. You just need to know how to formulate it, how to find those constraints. If you go to PhD programs, you need to understand what is the mathematics behind that and bring some innovation in terms of improving the algorithms. But it's really interesting topics. And just think, during the supply chain, which is everywhere, Amazon, Walmart, all of them has transportation problems because they have certain suppliers, they have customers, they have demands. And the next step is making stochastic demands because, supply and demands are not always deterministic like here. Some cases, you have seasonal demands or some probabilistic demands. So that's just next step after this. But the first step is, and you need to know how to formulate a simple deterministic problem. Okay, so there's just one thing left here. Next to this blue rectangle, you see that I put zeros, but if you click on, there's a formula. So if you see here, I sum up whole of this row. What does it mean? Can anyone guess what's the sum of this whole of this row means? In the columns, I have suppliers. In the row, I have a customer. What does it mean? The total possible delivery that customer can get. So, or basically, it's demand. So Dora, yeah,
across all columns. Yeah.
Mm-hmm. It doesn't mean that all of them supply for Dora, but maybe some of them provides. But at the end, we want the summation equal to 75. Or for EU, whatever he or she gets should be 400, or same for killer. So the raw summation basically help us to just satisfy customer constraint, because we know that we should fulfill the demands, right? So we need to see how much delivery those customers received. Is it at least their demand or not? Same for columns. Can I do it instead? Like if I click on this zero, it just summation of everything in this column. What does it mean? What this summation means?
This much Ocala can supply across all customers.
Very good. So is this the overall summation of, or total of goods that Ocala provide for everyone? So just this summation helps me to check if the total delivery, is it less than the Ocala's supply or not? It should it should be. It should less than supply cap. So Ocala cannot deliver more than 200 units. So here I just sum up everything that goes to the customer to check with the demand in each row. And in each column, the summation should be less than my supply cap. So basically the row sum and column sum is for checking the logical constants. Anyone has questions? I just wait 1 minute if you have any questions. Okay, so let's go to the solver and see how what I did in the solver. Basically, in solver, I just tell Excel how to calculate my objective function, which is in minimization, and what are my constants. So for finding a solver, under data tab, you can find solver, like, in the right part of upper right side of my Excel software. And as you see, we have a solver button here. So let me just click it. So the first cell, I'm just telling Excel where is my objective function. So my objective function cell is C12, which is for total cost. Excel would know that it should check this cell repeatedly, because simplex algorithm has some repetitions. Maybe there's a better term for that, but it has some steps. In each step, just check if total cost is getting less or not. Basically, if you might remember, in the graphical solution, we check each point, and sorry, the edges of the solution area or feasible area, and the one that has the minimum value would be our objective function. We just pick the point that minimizes the solution in the feasible region. So something like here, Excel in the feasible region, Excel check each point, and it just brings you the minimum possible point. Okay, now, and the next one, just telling, is a minimization problem. If you look at here, in the next option, I'm just saying changing the value of these cells and tell me where is, and calculate the objective function. But where are those? These are actually my blue cells, and as you see, there's a comma between them. So let me just do it again. So these blue ones, how many goods, comma, these blue ones. So again, this section, Excel would understand what are the parameters that needs to play with to minimize our objective function. Someone had a question, right? Or just the noise? Again, if you're not comfortable for using audio or video to ask your question, you can just send me a text so I can read the text and answer your questions. Okay, let's look at the limits. So let's see. The first one is a little complex. Let's just escape first one. I go back later. Look at the next one. I said H16 up to J16. These ones. Can you see my mouse? Let me see, someone just text me. If you can see, I'm happy with, okay, it's good. So H16 to J16 is this row, which is now 0. What does it mean? And check the other side of inequality. I said it should be less or equal H17 to J17. It makes sense. Right now the values are 0 because Excel didn't calculate the blue cells. But at the end, for Ocala, the amount that Ocala supports or delivers should be less than supply cap. So the second limitation is basically the supply or supply capacity constant. We want to say the amount that we supply or deliver should be less than our supply cap. This is our first logical constraint. Look at the last constraint. I said K12 to K14 should be more or equal L12 to L14. L12 to L14 are my demand cap, and K12 to K14 is the goods that are delivered to the customer. So logically, I want my goods more than demand. So I satisfy all my customers. You can change it to equality, that's fine too, but at least it's logical. You know, if I produce more, I lose money, but it's logical. Look at the third constraint. I just said H23 to J25, H23 to J25 is my lower rectangle. I said equal integer. So what does it mean? I don't have, all of the trucks are integer numbers. I cannot say I have 2.3 trucks. So the way that you, okay, I'll talk about this formulation later, but I think one of them is remained, okay. Okay, let me just, so if you look at this yellow rectangle here, it's multiplication of trucks to the capacity, 300, right? For example, at the end, I would understand, let's say at the end, Excel calculated and said you should send 2 trucks to Dora. So the yellow here would be 600. So the capacity of that link would be 600 in this yellow one. If I go back here, the upper blue rectangle shows how many goods should I send. So if the capacity is 600, in the first cell of the blue rectangle, I cannot put 800 goods because it's more than the capacity. And it doesn't make sense, maybe because you just need 200, why you should 800. Again, it's logical to produce more, but it's not economical. So what should I do? I should put a limitation for the capacity of the links, saying that this yellow is my capacity. The first blue one just saying how many goods I'm sending. So the quantity of goods in the first blue rectangle should be less than the yellow rectangle. So if you look at the first constraint, it's just saying H12 to J14. So H12 is the first cell, J14 is the last one. These ones should be less than N23, which is the first yellow cell, to P25, which is the last yellow cell. Again, these yellow cells are empty now because there is formula in it, and they calculate the capacity. I'm just saying that my delivery on each link should be less than the capacity of the link. And I put the formula here. Let me delete the third constraint, which is saying H23 to J25 is the second blue rectangle, equal integer. I'm just saying that they should be integer numbers. Let me delete it and type it again, because this is the challenging one. Oh, where does it go? Okay, now I see. So now I want to add that constraint. So first I click add, select all of them. Here I select int. For the value, first you should put 0. Now I change it to integer. It's a little weird in this version of Excel. If I select this again and go to change, now I change to equal integer. But the first time, we should put this one as an int, this one, and change this one to 0. But after you make it, Excel change it to equal integer. So again, let's look at the constraints that we had. The one constraint was for supply. Our production should be less than the supply cap. The second one is about demand. Our delivery should be at least equal our demand and more than that. Our number of trucks are integer. And the goods that we send over each link, each route between supply and customer should be less than the capacity of the link.
Professor, can you explain the last one?
This one?
Yeah, because it's saying that each customer demand is greater than the demand cap.
So again,
I'm not following something.
Okay, so if you look at K12 to K14, what we are saying that, the thing that are inside K12 to K14 is the delivery to the customers.
Yeah.
We are saying that delivery should be more than demand. We want to satisfy all the demands. Okay. You might say, why we can change it to equal.
No, like my question is, if there's a demand cap, that means this specific, say Dora is having a demand cap of 275, that means it should not exceed 275. Then how can we say that the total orders of Dora is greater than the demand cap?
It's not orders, it's just the products that is delivered to Dora.
Okay.
Maybe the wording is bad. Instead of demand cap, maybe I should put demand, just demand over there, but
okay.
I hope it makes it easier to understand. So our delivery should be more than demand. It's what I mean here.
Oh, yeah.
Okay, again, let me click on solver. And I just said if I didn't specify any parameters, there should be non-negative. Also, the method I just select simplex LP. This is just the mathematics behind of this solution. And then I just click on solve. You can have it as a separate sheet, but I just click OK. If I click OK, you just see all the answers here. So let's check what happens. So this is our total goods cost, truck cost, and total cost, which is summation of them. So the lower blue rectangle, you can see you should send one truck from Ocala to Dora, one truck from Orlando to EU, one truck from Orlando to Clay, one truck from Leeds to Dora, one truck from EU to Dora. And since the truck capacity is 300, here you can see the capacity of each link on the yellow rectangle. And you can check with this, the upper blue rectangle, and you see the links, the load that we put in each link are less than 300 here. So we didn't overbook the roads. Also, we can see here, I'm going back to Deepshika's question. So, you know, now the product delivered to the customers are exactly equal to their demands, which is what we want. We don't want to produce anything more than the demand because it's not economical. And so, again, what does it mean? When in the solver part, if you change it to equal, you get the same answer. I intentionally make it more equal or greater for this one. I mean, some probably need to provide more than the demand, but let's say here it's not economical, but it's logical. And for supply cap, you see that the production in all of them are at most our supply cap. Even in Orlando, we didn't reach the cap. We just deliver less than the cap. So let's say you get hired in the supply chain company, or the company has a supply chain. You can make a transportation plan and give it to the drivers, customers, and just plan ahead of you. So any questions? I just wait a little bit, so then if you don't have just 1 or 2 minutes, then I go to the next part. If you look at the word, the next one, I just said, what happens if the capacity each truck is 100? So if you look at the second sheet, here, I just changed the truck capacity to 100, and the rest is same. We didn't change any. Oh, let me just check the type here. Demand, supply cap. Then I go solver, solve. Look at the cost. The goods cost is same, but the total cost is more. Can anyone say what's the reason for that? Why, if we reduce the truck capacity, our total cost is more? Here it's 300, the truck capacity. Here 100. But my total cost is more. The answer is very easy.
Number of trucks will be increased.
Yes. So as you see, the total cost, the goods cost is same, 24K in both, but truck cost is more because if you have smaller trucks, you need to use more trucks. So it's the reason, truck unit cost is same, but you need to send more trucks. So it's the reason your truck cost is more. Okay, I give you like 15 minutes as a break. Please take a rest, and we go to the two of the applications remain. So we go to the next two applications after the break. So please come back in 15 minutes. Thank you. Okay, everyone, we get back to the slides, and let's see if you can see my screen. Okay, great. So let's look at go to the scheduling problem. So let me read the problem. As a manager of a call center, by the way, can you hear me? If someone can just send me a text so I understand if you can hear me. Okay, that's great. So as a manager of a call center, you have to make sure that on each day a minimum number of workers are required as listed in the table. So we have 7 days a week, and each day you can understand how many workers are required. So each worker can given one of 7 plans available with 2 days off. Your objective is to minimize the cost and make the decision that how many times each plan will be assigned. So let's say in the first plan, there's Sunday and Monday is off, second Monday, Tuesday, up to the last plan, which is Saturday and Sunday is off. And you see that the salary that you need to pay for the workers that come from each plan. So let's say if you're for Friday, you need 21, and you get all of them from first plan, which their days off are not in Friday, they're on Sunday and Monday. The money that you need to pay is 21 times 680. So having said that, we want to satisfy the number of required workers and also minimizing the cost. Actually, it sounds to be a very easy problem because the number of workers that are required is something like demand. And you supply from different plants, and the delivery of the workers or the amount that you provide should be more than the demand here. So we just have one constraint seems to be here, and the second one could be just we need to have integer number of the workers. It doesn't make sense that you say you provide 22.3 person. So it is actually is an easier problem, but it's just different application. And again, you need to expose yourself to such a problems to get more familiar. So the next problems just gets easier and easier. Having said that, let me just open the relevant Excel file. So our objective functions minimizing the cost, and total cost is summation of employees to number of to their plan cost. Let's say for the first plan, if we need 10 employees, the cost of the first plan is 680 times 10. Oh, you cannot see the Excel file? Oh, sorry. So, okay. So again, the total cost is the summation of number of employees to each plan. Our objective function minimizing total cost. And we know that we should satisfy our demand and number of, oh, sorry, there's another typo here. Number of employees are integer. So here you can see expansion of the demands, the plans. So plan 1, Sunday, Monday, 0 means off. The rest is 1 means they are not off. Second plan, the first day Sunday isn't off, but Monday and Tuesday are off because they're 0. And same up to the plan number 7. Again, the blue cells are the cells that are calculated, that should be calculated by Excel, and the yellow ones is the formula that we put there. Okay, anyway, so we also, if you look at the Word document that I shared with you, you know how many workers you need in each day. So for example, on Sunday you need 18, Monday 27, Tuesday 22, up to Saturday that you need 19 employees. Look at this in the row number 14. You see so many zeros. These are empty cells, but they come from calculations. So, oh, sorry. So what does mean here? Let's say I have 100, not 100, let's say 5 employees from each plan. So in these blue cells, each of them is 5. Means I pick 5 from plan 1, 2, 3, 4, 5. So we know that from plan 1, nobody works in Sunday. And also from plan 7, nobody works in Sunday. But total employee that, if I pick 5 from each plan, the total number of employee in Sunday would be 5 plus 5 plus 5 plus 5 plus 5 would be 25. So here basically summation of either we have an employee from each plan or not, 0 or 1 times number of employees that Excel would calculate for us. Again, if the answer here would be 5 for each day, We know out of those 7 plans, 5 of them brings employee for us on Sunday, so summation of them is 25, and it's more than 18. We need 18 employees on Sunday. Since each plan we got 5 employees, the total available employees on Sunday would be 25, is more than our demand. So sounds to be logically true, but maybe it's not very efficient, because if you hire 5 employees from each plan, you have some extra employees like on Sunday. It's not economical, but it's logical. So based on number of employees that Excel calculates for us from each plan, we can in this row we can understand how many employees are available on each day, then check if it's more than our demand or not. I just wait like 1 minute if you have any questions, otherwise I'll go to the next part of the Excel. So it's a little weird, but it's the way that I can understand if you have any questions or not. Okay, so the next part is just total cost. If you know how many employees we have from each plan, we just multiply to the cost of each employee from each plan, and it gives us the total cost. So if you click on total cost cell, you can see it's just equals sum product of the number of employee columns to cost column. Let's go over solver. In the solver, first option is just raise my objective function, which is total cost, and I select here. In the second option, it says the minimization problem, because we want to minimize the employees' salary. How much we pay for the employees. But we ask Excel to play with these blue cells from L7 to L13. And based on the solution Excel finds here, we can calculate our total cost. In the first one, we said E14 to K14, these zeros, so should be more than E15 to K15. E15 to K15 is the row that shows our demand in each day. E14 to K14 just show how many are available. So we know the availability should be more than demand. The second constraint is just saying that the values that you find for the number of employees should be integer. It doesn't mean that we have 2.3 people. So all of them is integer. If it didn't specify any other constraint, we assume that they are non-negative. And also in the last option, we choose that use simplex LP or linear programming to solve the problem. So I click on solve. Okay. So you see that almost we have employees from each plan except for plan 4. No one is selected. And if you look at the demand limitation, In some days we have more demand, more than the demand. Like Friday we have 24, but we just have 21 works, 21 employees needed. Same for Thursday, Wednesday, and Tuesday. So in these days we deliver more employees than is needed, but it's the only way that it's solved. It couldn't uh, reduce costs more than that. So I just wait a little bit, then could go to the next part of the scheduling problem. See if you have any questions, or you can play with this. Let's just play with this Excel file for a few minutes. Then I go to the next. So you can just play with the Excel file, change some number of employees, or you can change the cost and run it again. So just do that. I just give you like 5 minutes to play with the Excel file. The thing that you can change is the daily demand and plan cost. See if you can get some results. You can play, as you see, let's one of them, I do one of the plays by myself. So nobody selected from plan 4. Let me just reduce the cost. So instead of 705, I make it 400. Let's solve it again. Now 8 employees are selected from plan 4. So you see that there's such a thing. So you can make some strategic decisions later, how to play with the plan cost or like daily demands, and you might get different results. So anyway, I give you like 5 minutes to play with the Excel file and change the parameters. Sometimes you change parameter and Excel couldn't solve the problem. Maybe there's no answer for that. But let's see. So meanwhile, if you have any questions, you can ask me. So So there's no question. So let me go to the second part of the assignment. So as you see, we have 4 jobs and 8 workers. So workers, instead of having workers name, we have A, B, C, D, E, F, G, H. And having said that, let me read the problem. So there are 4 jobs and 8 employees. You have to assign 1 job to 2 workers. So basically, let's say for job A, maybe you pick A and B. For job 2, you pick C and D, and so on and so forth. So you have to assign 1 job to 2 workers. One more issue is that E, F, and G workers cannot be assigned. So I have actually some similar problems in your project. So sometimes you say, I don't want to work with this and that. So it's kind of similar problem. So workers E, F, and G cannot be assigned together to any job, but one of the 3 can. So the constraint would be that among E, F, and G, either one or no one can be assigned to a job. And also, in the assignment problem, you want to minimize the cost. So actually, we added a constraint here that the 3 cannot work together. Okay, so in this problem also, here, the first step you see the cost of each assignment of each worker to any specific jobs. And the blue one, again, is the cells that are calculated with Excel. So the value is either 0 or 1. If 0 means no worker, and assigned is 1 means 1 worker is assigned. So assignment column is 0 here because it's a formula. I'm just saying that this summation of everything that I have in row, what does it mean? I know for job 1, I may assign A, B, or C, D, E, F, whatever. And the other cells would be 0. So again means, whatever I assign should be at least 2. Because this row is basically how many workers are assigned to the job 1. And we know that should be at least 2. Same for job 4. So 2, job 3, and job 4. And the summation of columns, it just showed that how many times A is assigned to the jobs. Same here, D, E, F, G, H. And there is a cap, because we know that if you assign worker 8 to one of them, you cannot reassign to other job. So cap 1 means, here just means 1 assignment. It just means A cannot assign to multiple jobs, or B, C, D, F, G, so on and so forth. So now we can check two limitations. First, we should satisfy 2 employees for each job. And we can check it with the assignment column. Also, we should satisfy another constraint. At the end, it shouldn't be more than 1. I got some error about the internet connection. So if I lose the internet connection with you guys, no worries. I mean, I make video for the remaining of the class, but hopefully that issue won't happen again. But I got a warning about the internet connection. This yellow cell is about the calculation of the cost. So we just times whatever assignment plan interesting column. Look at the column EFG not working together. The first one is summation of I14 to K14. If you go to the second one or third one, just some summation of EF and G for job 3. So each time we check either these 3 is it like more than 1 or it's not. I have a question. Let's say I do run this formula and the summation won't be 0. Instead of 0, maybe it's 2. What does it mean? Again, the formula just means we check the assignment of EFG for job 2, 1, 3, 4. What if, like here, I get 2? What does it mean? It's a question. Can anyone answer?
It's like two of the 3 workers are working on the same job.
Oh yeah, that's a really good answer. And it's not good. So if it's 2 here, means I'm not satisfying this constraint. I said worker EF and G cannot assign together on any job. If here you have 2, means maybe this one is 1 or this one is 1 and this one is 0. So, but if all of them are, if this one is 0, oh, let's see. Okay, I just screwed the formula. So if this one is just F is 1, this column, this associated set in this column is 1, 2. If I use G, it changed 2. What does it mean? I assign F and G together. Basically, I made this column to check how many of them are assigned together in a specific job. I give you a couple of minutes to play with this Excel file, then I go to the Excel solver. So you can see how those formulas works and how those association, why I put some specific calculations there and other parts. Okay, let's go to the Excel solver. Again, the first one is cell O11, is total cost. We are telling the Excel that you should check the cost here and minimize this cell, because in the second one I pick me. And look at the first constraint. I said E20 to L20. It should equal E21 to L21. Here I don't put more or less, because at the end we want all the workers to be assigned. So it's the reason I put equal. Didn't put, like, if you remember the previous problems we had more or less, but here I just put equal. Second constraint, I said M14 to M17, which is assignments, should be equal to. So we don't want to provide more than required workers. So if it's just in 2, let's just assign 2. And you know, we have 4 jobs and 8 workers, and each job needs 2 workers. So, and again, another reason that they are equal sign, because we need exactly 2 assignments for each job, or we need all the workers to be assigned. So here we have equal sign. But the last one is more interesting. I said P14 to P17, which is for EFG column, less or equal 1. If they are equal 1 means one of them is assigned. If 0 means none of them is assigned. But they are not, could be 2 or 3, because if it's like 2, it means 2 of them assigned to a specific job. Again, solving method is simplex, and I just click solve, and okay. So if you check EFG, or EFG column is either 0, 1. For each required assignment, we assign 2 workers, and all of them here is R1, means all of the workers are assigned. The minimum cost is 15, 50. I give you 1 minute to see if you have any questions, or 1 or 2 minutes. Then if there is no question, I go to the next problem. It's very interesting. I think 3 of you just stopped watching I stopped attending the class, the online class, because I just see we have some drops of you. But anyway, no worries. I think 3 of the participants left the meeting, but that's okay. So if there is no question, I go to the last problem. The multi-step transportation problem. Just close this one. Let me read. Orange are produced at Orlando, Phoenix, Austin, and San Francisco. The production at each place is given. So you see 240, 240, 180, and 170. You see negative signs. No way, it just means they are going outflow. So the reason they are negative, but there's not that much of difference about how to solve it. So for Kansas, you see 200, Omaha 300, and Chicago 150. Orange are finally required at Kansas City, Omaha, and Chicago requirements and costs from warehouse argument. So on each node, you see like requirements and also capacity. Also on the link, you see 24142, whatever. These are the transportation costs. Objective is to ship oranges from warehouse and then to store with minimum cost. Here, again, the way that you formulate it might be different because you can assume the warehouse inflow is equal to outflow, or you can assume outflow is less than inflow. Both of them is okay. And also, if you want to make it a more complex problem, remember you add a warehouse cost. But here, we assume that in Denver, Springfield, there is no cost, and inflow equal to outflow. Again, these are arbitrary assumptions to make the problems easier. So, let me just go to the solution for now. As you see, the total cost of transportation cost to warehouses and from warehouses. Objective function is minimizing the cost. We should satisfy demand. We cannot deliver more than what we supply. And warehouse in equal warehouse out. Again, especially the last one is kind of arbitrary. You can assume warehouse in should be less than warehouse out. But you cannot say warehouse in more than warehouse out. That's not logical. So you see these two tables, two warehouse costs. This is actually come from this figure. So two warehouse, from Orlando to Denver. To the Denver warehouse, you should pay 3. From Orlando to the Springfield warehouse, you should pay 4. And same for others. So these links cost just is used to make these two tables. The first table is just the transportation cost to the warehouse. Second one, transportation costs from warehouse to the customers. And in this problem, we need to know how many goods should be sent from each link. So first blue rectangle is for transportation costs to the warehouse. We have two warehouses, so to the warehouses. And second blue rectangle is for calculating how many goods should be sent from each warehouse to the destinations or customers. So these blues are what Excel would calculate for us. And again, yellows are our formula. So the first formula is associated to the goods that we send to each warehouse times the cost. So it's 2 warehouse costs. The second yellow set from warehouse costs. So we have a table for transportation from warehouse to destinations, and also we know the transportation cost of each link. And total cost is just summation of these two. Let's go over solver so you can see the constraint. So again, first one, we just said we want to minimize the cost in T18. It's a minimization function. Look at the first constraint. W stands for warehouse, D stands for demand, and S stands for supply. So in the first cell, you see how much goods you send from first warehouse to the first demand. Second cell, how many you send from first warehouse to the second demand, and same up to the end. This 30 means how many goods you send from warehouse. A similar logic for the earlier table. In the earlier table, we have S and W. S means the goods that you send from a supplier to the warehouse. So the rows sum is basically how much you make from each supplier. And the column sums are basically how many goods you deliver to each warehouse. Anyway, again, let me go to solver. So first one means your delivery should be more than your demand, so you should satisfy your demand. Second one, just saying I24 to J24, so I24, J24. These are the inflow of warehouse. We're just saying that how many goods are delivered from supplier to the warehouses should be equal to L29 to L30. L29, L30 is this one. You're just saying these two again are outflow of warehouse 1 and warehouse 2. Basically, this equal sign means whatever you send into the warehouses, they should get out. So inflow, left side, equal to outflow, right side. Third constraint. L21 to J, sorry, I think it's probably I24 to J24. These are warehouse caps. Are less than I25, J25. So basically, what does it mean? Our warehouse capacity is 400 and 300. Whatever comes to them should be less. So we cannot store more than 400 in the first warehouse or more than 300 in the second warehouse. And last constraint, K20 to K23. So K20 to K23. supplies. So whatever supply that we deliver from S1 to S4 supply should be less than capacity. So we cannot supply more than our capacity. Again, we solve it through simplex, and when I click here, yes, go ahead, please.
The second constraint,
Mm-hmm.
where we are saying that the warehouse received should be equal to warehouse cap, that is inflow and outflow. So
you mean I24 to J20?
Yeah, right, the second one.
Mm-hmm.
So will it be exactly equal or should be less than equal to equal? Like,
actually, you can put it in that way too.
okay, but that shouldn't be any problem when it comes to answer, right?
Yes, if I ask you in the exam, I just want to see. I see your write-ups. It based on different policies that you might have. Both answers are right, are logical. As long as it's logical, that's fine. But you cannot say your outflow is more than inflow. That's not logical.
Right. But until and unless it's less than equal to, that would be fine, right?
Yes.
And will it going to change the answer?
Yeah, it might change. You know, the way that we formulate is based on the reality. If we just see how warehouse works. Let's say you get if you want to formalize a real problem, you just see how those warehouses works. Maybe at the end of the day, you can store something in the warehouses. So you can put, instead of equal, you put less. But maybe based on the industry that you work, you don't store it. Just, you temporarily store, but at the end of the day, inflow should be equal outflow. In that case, you put equal sign. Both of them are right in my point of view.
Okay, thank you, Professor.
You're welcome. So if you solve it, you get the answer. So inflow cost is 1319, outflow or from warehouse is 950, and total cost is 2314. And you can understand, for example, you don't send anything from like supplier 1 to the warehouse 1, but you send 80 to the warehouse 2. And as you see, all the constraints are satisfied. And that's it. So I give you like 5 minutes to play with that. Maybe you can change some parameters. Like as Deepshika said, maybe instead of equal, you said less or equal. And you can see what different results you might get. So having said that, let's look at the second method. So you don't have to follow the second one. Second one more is a creative way of doing that, but and you can find so many other types of doing such a problems, but you don't have to follow that. Basically, in the second approach, we specify inflow with a negative one, outflow with 1. For example, from Orlando to Denver, -1 means outflow, and Denver was a warehouse, so the cost of transportation is 3. And same for Orlando to Springfield, or like Springfield to Omaha. So based on outflow of the supply has the coefficient of -1, inflow to the customer has a coefficient of 1. So basically here we put the links that we have in our network. 1 means the link is associated to outflow, inflow. -1 means to inflow. And we ask Excel to find how much we send from each link. These are in the blue cells. And also we have supply cap and the demand. These zeros are comes from our calculations. So basically, if I click on one of them, you can see summation of basically -1 is just a coefficient for inflow outflow times the blue cells that Excel would tell us how many you sent. And same for the others. It's not the way that I recommend, but just a creative way of doing that. So let me look at this. And also we have then DNSP, stands for how many would be in our Denver warehouse and how many in our Springfield warehouse. And also total cost is just multiplication of the blue cells that are how many we send in each link and cost of transportation. If you look at the constraint, the first constraint is just saying that you should be more than your demand, which is positive, and you should be more than your supply, which is negative. More than a negative sign means the absolute value is smaller. So basically, if you're in Orlando, you supply 240, like -100 is more than 240, and we know the absolute value is 100 is less than 240. What does it mean? We deliver less than what we supply, which is logical. We cannot deliver more than what our supply can. And also, the last constraint is about the capacity of the Denver and Springfield warehouses that I said it should be less or equal 40. You got the same answer. Again, this is just a creative way of doing that. I just wanted to show you you are not limited to just that way. And you might find more creative way, but just keep in mind that another approach to formalize the transportation problem. I give you a couple of minutes to play with these two methods, like the first one and second one. Then I go to the second question. Okay, second part. Two, there is a loss of 10% oranges in each transfer. In other words, 90% of the oranges reach from source to destination every transfer. Source to warehouse and from warehouse to the destination. So now problem is more realistic. We know that we have a lot of waste in the transportation of vegetables or fruits. So we want to see what happens if we have some loss. First of all, although we have lost 2 times from supplier to the warehouse and from warehouse to the customer, we need to satisfy our customer demand. So what does it mean? Probably you need to produce more, because at the end you lose 10% of them in each transition parts. But the other limitation should be same too. For example, inflow of the Denver should be equal outflow, or as Deepshika said, maybe some problems your outflow should be less or equal inflow, also fine. But you keep that. And also, you know that you produce more, but at least your more production should be less than supply cap. Another thing, you produce more, but or you just produce regularly, you waste some or you lose some in the transportation warehouse. But again, inflow after loss should be equal outflow based on this problem. I give you a couple of minutes to think about that, how it change our formulations. Then I'll go to the solution. So pretty much looks like the previous problem. We just have, probably we need to change some coefficients because we have some loss. And if you have any question, you are more than welcome to just interrupt me and ask your questions. But I give you like a couple of minutes to think about the problem.
So Professor, that means supply should be, just an example, 10% higher than demand, like in ideal situation.
I mean, I got your point. That's right, but you know, not uh, exactly 10%,
Yeah, right.
because
No,
you lose
yeah, right.
yes 10
Plus, yeah.
yes raised to power of 2, right?
Professor, when this type of questions will be like given in test or in homework, so we also need to consider all the moving parts or just whatever is there in the questions.
You know, you can have some assumptions. Let's say your assumption is that outflow should be less than inflow, but just specify them clearly, that should be fine.
Right, because what I'm thinking, like, for example, in this case, maybe some of the quantity is there in the warehouse. So that is also taken into consideration when we are supplying the fruits from the warehouse to the customer. So, but these moving parts should be considered, should not be considered when answering the question.
It's better to consider it. It makes it, I mean, more advanced.
Okay.
Also, in real cases, you can make this problem even harder considering some warehouse costs.
Right.
Or make it more complex. I mean, these are just different type of problems that if you just see them one time, you can, next time would be much easier. So what happens if you work for 30 days? So you keep something from last day in your warehouse, you pay for the warehouse cost, and next day you send them to the destinations. So as I said, just gets more complicated each time.
Yeah, true.
And I had an advisor. His PhD was in operation research.
Mm-hmm.
His dissertation is about solving a problem in the railroad industry.
Okay.
He told me his computer was running for 10 days to solve the problem.
Okay.
Because if we add more, just makes your problem more realistic. Like here, adding food loss, adding warehouse costs, maybe make it a stochastic instead of deterministic. It just brings so many problems. Your feasible region gets so large that it takes a lot of time for your computer to solve.
Right, agreed. And because like some must have taken seasonal also into this thing, like in summers fruits gets rotten more easily as compared to winter.
Yeah, very right. Yeah, I mean, these kind of problems, you can't just
But this becomes very complicated, isn't it?
Yeah, I mean, the reason it took like 10 days for him to solve the problem.
Right.
I think he said like 10,000 variables, like maybe 3,000 constraints, something like that. It was so large. Here we just have like maybe less than 20 variables, but just when it gets hard, more realistic, you just keep adding more variables.
Right.
Yeah. So if there's no other questions, let me go to the solution. So as you see, maybe I can just delete these ones, just there's some zeros. So it's still, we have a glutate, oh, let me just make it larger again, so not this much. So we still have a two warehouse table. So we sent from Orlando, Phoenix, Austin, and San Francisco to Denver and Springfield. And we still have the second table, which is what we sent from those warehouses to the destinations or customers. So as you see, Sorry, I just hit something. No. So I put coefficient of 9 because I know that whatever I send from my supplies to my warehouses should be multiplied by 9 because it's what goes to my warehouse. So you see an actual yellow table here. It's just saying that what happens when it gets to the warehouse. So the first blue one is what you produce. This giant yellow rectangle just saying what your warehouse receives. Similar to the second table, you know how much you sent from Denver and Springfield to the Kansas, Omaha, and Chicago. But you know, whatever you send, you should multiply 2.9 to see what they receive. So again, the first blue rectangle is just what you produce in each supply and send it to the warehouse. The first yellow means what your warehouse received from different supplier. The second blue rectangle just means how much you sent from your warehouse to the customers. And second blue yellow table means what your customer receives from each warehouse. But the limitation of now is a little different. So basically, we should satisfy demand after the double loss, because whatever you send from supply to the customer, it would be lost 2 times. Each time it lost 10%. We cannot deliver more than supply before loss. So whatever even you produce here shouldn't be more than your actual supply. Warehouse in after first loss should be equal warehouse out. So whatever gets to your warehouse that's affected by 10% should be equal whatever you send from your warehouse. If I go to solver, so look at the first constraint, H33 to I33. So these two should be less than H34 and I34. What does it mean? Whatever I deliver to the warehouse should be less than warehouse capacity, which is 400. And you know, this summation of those warehouse delivery is already affected by 10% loss, because I multiply the blue one to 0.9 and I get this here. H33, I33 should be equal O17 and O18, or Q, or Q. So these two, H33 and I33, it's just whatever gets to the warehouse after loss should be equal Q17 and Q18 is what gets out of my warehouse. So as you see now, the concept is a little bit changed. So what I'm checking for inflow of warehouse comes from this yellow rectangle, not the blue one. And again, inflow equal outflow. The third constraint, J16 up to J19 should be less than K16 to K19. So What does it mean? Whatever you produce in each supplier should be less than supply cap, which is same as what we had before. And the last constraint, N31 to P31. So this row, I hope you can see my mouse, is whatever you deliver from your warehouse to your customer after the second loss. Should be more than N32 to P32. Should be more than your customer demand. So the last constraint, just saying that whatever you still have after second loss should be at least more than your customer demand. So I wait a couple of minutes. If you have questions, then I go to the next one. Okay, let me just solve it. So now my cost is 29.46, which is like a significant increase in the cost. So before, without loss, my cost was 23.40. After considering the cost, is 29.46. You see the huge increase in the cost because first of all, I need to produce more. The second, because of loss, I need to transfer more because I know that 10% of them would be lost, so I have more transportation costs too. So increasing the transportation cost and also increasing the production cost. The second way that you do it is actually, again, this is the creative way of doing that. You don't have to do. Basically, you still calculate the amount of goods that you send from each link. The only difference is that your cost now is a little different. So it's supposed to you should consider the whatever 0.9 as a change in the cost, and let me just go again. The other is almost same, and I mean, you just Excel run, let the Excel run, and you get the exactly same answer. So let me see what I wanted to show you. Okay, let me go to solver. Oh, not this part. So look at this part of the approach. Let me make it with blue. So, I already told you that negative sign means inflow from supplier to the warehouse, and positive means from warehouse to the customer. So, and now inflow plus outflow, it's negative. In the previous one, it was 0. The only reason for that, you know, the inflow that we send to the warehouse, you lose 10% of it, and then you send from, so actually, if you multiply inflow by 0.9, then it would be exactly equal to outflow. But here you don't see that multiplication. It's the reason now inflow plus outflow got negative, because you have more inflow since you are losing 10% of it. Then it's like, in terms of quantity, it's a little more than outflow. Anyway, that was for today. I know that might be a little difficult for you because the first time you see such applications. You don't have to follow any creative way like these approaches. So for each part of the problem, I put method 1 and method 2. I'm personally even more fan of the method 1 is because it's more standard. So it's less confusing. But if you're happy with the second methods, you can just use them. That's totally fine too. But in your exam, I don't ask you to do this method or that method. I just ask you to find the solution. So either ways is fine. Just see which one is more comfortable for you. But I mean, and also same as what Deepshika said, you might have different assumptions. But if you follow different assumptions, you should clearly specify what was in your mind and why you picked that specific formalization. Anyway, that was for today. Thank you very much. So today we have too much of teaching. So I'm going to post some homeworks for you, and please also work on your final project to wrap it up. And also, if you are selected for the second round, please, you can work on your contents. And if it's your final project same, I can consider the same presentation, and you don't have to make it twice. Cool. Thank you for today, and have a great evening.
Professor?
Oh, you have a question? Sure.
Yeah, no, sorry. No, for the assignment today, I submitted all, like, it's in a Word document.